Good afternoon, everyone. We're from Group 10, and today we're going to be discussing our case study, which is case study 1, which is classroom seat arrangement optimization. We are Jan Lauren Sigurs, Gabatan Dindia, Fatia Zara Santoso, and Benedicta Rachel. Firstly, I'm Jan Lauren, and I will be explaining about the background. So, our proposed classroom setup, there are a few key points that I'm going to be highlighting, which is the first one is the daily seat rotation. It promotes fairness, inclusivity, and interaction among students. And there are also fixed seats for students with special needs to ensure comfort and access. The first one is S1, which is located in front left for better hearing, and the second one is S2, which is located in the front center for clear vision and lighting. Next.
Okay, let me introduce myself. I'm Rachel, and so let's start with the classroom floor plan. Our classroom layout accommodates with a maximum by 30 students, and it arranged in 6 rows labeled A to F, and also 5 columns labeled 1 to 5. Next page. We also include a clear flow path to show how students move or even rotate seats throughout the week. And as you can see, each seat has its unique ID, like A1, A2, A3, until F5.
Let me introduce myself first. My name is Fatia Zahra Santoso. So from this slide, we could see that it's the visualization from what Jan actually mentioned. So S1 is placed at the front left, while the S2 is placed at the front center. And then moving on to the seating arrangements, we made it into a 5-day cycle. So this for row for column A, C, and E, they will move 1 seat backwards, and then for column B, D, F, they would move to the back and then move forwards. This applies to all 5 days.
My name is Gilberto Ninja, and these are the key factors that influence how the seating plan is arranged. Students are grouped based on academic performance to balance learning and peer tutoring. Certain students may need to work together or be separated based on their roles or compatibility. Students have preferred peers or spots, while flexibility increases comfort. It can lead to seat competition, social exclusion, or distraction among friends, and students with a physical challenge or vision problems must be placed in accessible seats such as near entrance or whiteboards.
Let me introduce myself again. My name is Fatia Zahra Santoso, and from here we could move on to the pattern recognition. We divided it into 4 different variations, but the first one is the same row number. It's identified from the row number where the upper and the bottom one is placed at the same position. And then for the next one is returning to the original pattern, which the day 1 pattern would then repeat at the 5th day. And then for the third one is the zigzag patterns, which for the upper column is this differentiated like distance one seat behind it or in front of it. And it's divided into a day 3, day 4, day 5. And then moving on to the last one is the same color combination for row 3 and row 4.
Okay, I'm Benedicta Rahel. And so once we identified the seating patterns, we also organize all the information into structured data. And each element of the matrix, it also represents a seat, which is A1, A2, A3 until F5. And we also can divide 2 sets of constraints, which the first one is hard constraints. And the hard constraints is the one that needs to be satisfied, and also soft constraints, which are optimization's goals. Next slide. Okay, so further classified the classrooms into zones. The first one is front zones, which closest to the whiteboard, A1 to A5. Middle zone seats from row B to E. And also back zone, it's the row F, which is the farthest from the board. Okay, so this is the data representations. With data 1 is the seating positions that define the row, the seats, and also which row that is located. The data 2 is the student list that consists of the regular students, the S1 and also S2 students, and each conditions of them. And this is the data 3, which is the rotations flow or the pattern, and in which day 1 until day 5 we can see the flow directions from the patterns, and we can see the difference from day 1 to day 5. And this is the last data, which is the data 4. This is a special condition or the fixed variables, which consists of S1 and S2 positions. Okay, and this is the input, process, and also output. The input itself, current seating matrix, rotations rule, 5 seat exceptions, process, apply rotation patterns, and also output, updating seating matrix.
Moving on to the algorithm. Basically, algorithm contains like the steps in order to solve our like seating arrangement thing. So the first one is to initialize the layout. We define the total seats, which is 30, 6 rows and 5 columns, and assign the seating ID, which is A1 to F5. Then classify the zone, which Rachel have mentioned before. And then step 2 is to identify the special conditions, which is S1 and S2. And then for the step 3 is to assign the remaining students other than S1 and S2. Next. And then for the step 4, the crucial part is it's to apply the rotation rule from day 2 to day 5, which Tia have said before. The day 1 to day 4, they move like the column A, C, and E moved from our perspective moved downward. And for the column B, C, and F, it moves upward, and then it rotates back on day 5. And for the S1 and S2, it's still constant. And for the step 5, which is to validate the arrangements, we check all the accessibility constraints that are met. Next. Okay, and then for the output result, is the display seating metrics for each day, which is day 1 to day 5. Next.
So this flowchart illustrates the algorithm. The process begins with defining room layout and identifying students with accessibility needs who are assigned to specific mandatory seats. Then remaining students are assigned to available seats, and the system calculates a fitness score based on the factors. On the next day, rolling system is applied and fitness score are compared. The loop continues until the best sitting plan is found. That plan is then finalized as the current sitting plan. This pseudocode translate the flowchart. Same as the flowchart. First, it defines the total number of students and the seat layout until the output is come out as the best sitting plan.
Okay, my name is Rachel. So here's another pseudocode based on seating rotations. So it begins by setting the total number of students, and the pseudocode itself, it will ensure that special needs students remain fixed and no duplicate error. And the result is clear, and so it shows the repetitions of routines. Next.
Okay, my name is Jin, and then next are the BICO analysis. It's basically the same with the algorithm I've said before, only we point out N is the total number of students, which is 30, D is the total number of days, which is 5, and F is S1 and S2. Next. Okay, so these are the steps. Can continue next. And the result would be on the table on the right side. Okay, so that'll be all from us. Thank you.
Thank you.